Hi, everyone. I'm Alexandra Mousavizadeh. I'm the co-founder and CEO of Evident. We are the creators of the Evident AI Index that measures businesses on their AI adoption rates. And I'm sitting here in London. It's freezing cold. And Jack, you're in San Francisco. Hello.
Hi from the Bay Area. It's a bit chilly for the Bay Area here, but that's usually the case. So it's all good. Good to see you, Alexandra.
Good to see you. It's exciting times right now, and it's great to have this conversation and look forward to digging into sort of what's going on in this intersection of AI and quantum. But maybe we just take a step back and Jack, tell us about how you started on your career. You got recruited into Google to start Sandbox, and you have many books under your belt as well. So give us a little bit of a background on you, and then we'll dive into what you're doing now.
Well, great to be Alexandra. This is a very exciting time, big inflection points on both AI and quantum, and hopefully this time for us to get into the interaction of these two engines of compute. I started my career as a research fellow at the NIH, the National Institutes of Health, and as a scientist there, I realized that neural networks would be a key tool that we want to try out to tease out patterns and insights from brain images. The brain images that I focused on in my research are not static brain images, not the kind you might see like on a light box. Hey, let's see how the brain looks. These are functional images. And so these are modalities such as fMRI, functional MRI. That means making MRI into a movie camera, essentially, rather than just a still photo camera. PET and SPECT, PET and SPECT, these are two other modalities that look at function of the body and the brain rather than just how does it look. And functional imaging is so fascinating because if you had a problem with your car, you brought it to a mechanic, just taking a picture of the engine probably doesn't help. But seeing the engine run and hearing it run and watching it run probably is what's going to help diagnose the issue. And the same with our brains. And the files that come out of a functional scanner are so big and so complicated that human eyes are not really set to understand and see the differences between medication states of the same person, medication 1, medication 2, placebo as an example, or two different conditions of two cohorts of people. And so I turned to neural networks, which was just emerging at that time to understand if we could use this tool. And in fact, it did work. We didn't have very advanced compute. We didn't have GPUs at the time to use here. NVIDIA was just beginning as a company, and they were focused in the graphics world of videos, not in the AI world yet. And so we had to pull together all kinds of interesting compute platforms and write the code ourselves. No, there were no packages to download. We had to write the code ourselves to make all these neural networks happen. But the good news is it worked. Even with the early stage compute that we had and the basic idea of backprop and neural networks, it actually yielded insights as to different medication states that we had the patients in and or different cohorts of individuals with different conditions. And so that gave me the vision that one day I would love to build a platform that would apply neural networks to a broader range of not only medical issues, but also the biggest challenges in the world. The deep impact we can have in energy and financial services and materials and cars, automotive, space. And that's the vision I carried with me for many years. Alphabet came calling and said, hey, we're going to launch this thing called Alphabet, and that's going to be the parent company to Google. And you could start something in there and let's see where it goes. And, it was unknown what would happen. But what I said to the folks at Alphabet, I think these twin engines, the AI engine on the one hand, neural networks and distributed nodes to compute, as well as quantum would be the two key engines that I think would propel us to push the frontier ahead. And so we did start Sandbox and then added AQ, SandboxAQ, A for AI, Q for quantum. And along the way, started writing some books to help folks. I kept getting lots of questions from people, Alexandra, about, hey, what is this technology? How do I use it? What are some technical details around it? And so I wrote a book on quantum technology initially. It's a pretty technical book. It's used mainly in universities. It's a textbook. It has a companion GitHub site with code on it that you can download. But I think what I'm hearing from readers is it's helpful to folks as an on-ramp into the quantum world, and that's now in its second edition. So I guess people are enjoying that one. And then the new book coming out is AI or Die. I'm sure you, Alexandra, get tons of questions from banks, from many others in business. How do I use AI in practical terms? And that's what I wanted to get to in AI or Die. There's a lot of general theory books around AI. There's a lot of social discussions of AI and responsible AI, all very, very helpful. But this book, AI or Die, is a playbook. It's a step-by-step playbook for businesses how to deploy AI across about 8 major sectors of the economy. That one's coming out soon.
That is going to be, I'm sure, is going to be much in demand. It's as you said, it's a question that we, of course, get all the time. It is, how to deploy it. What do we need to? How do we prepare best for it, and how do we actually get AI into deployment and in the hands of all of our employees? But before we get into sort of the sectors and the value creation, I thought maybe we could just dig into when you talk about large quantitative models, I wonder if you could just double click on that for a second and then talk to us about what the difference is between these LQMs and the large language models, the LLMs. So, Jack, what is an LQM, and what is the difference between an LQM and an LLM?
It's a fundamental question, Alexandra. I'm glad we're going to kick off with that. I think a lot of the press, a lot of the attention has been on large language models, and deservedly so. These are incredible models, kicked off with the development of the transformer. It's a type of neural network architecture kicked off by a paper called Attention is All You Need by colleagues of ours at Google. My core group that I started building inside Alphabet was really around numbers, was really around the majority of the economy, 80% of the economy, that's really driven by mathematical relationships. And that could be in financial services, where fundamental to both asset management, risk management, investing, capital markets, debt markets, all this are numbers driven. They're driven by equations that help us understand the risk, be it the Black-Scholes model or DCF or whatever models we're looking at there. So the insight that I carried with me from those early days at NIH to today is that that's where we were going to focus. And that means that instead of looking at large language models, very useful, lots of applications, we started to develop large quantitative models. Models not trained on Reddit, not trained on cat pictures, not trained on social media, but instead trained on chemistry, biology, engineering, physics, quantitative finance. These domains that drive so much of the B2B economy. And so I think this coming year now, Alexandra, as we just are entering this new year, is exciting because I think there's been great progress on the B2C side in terms of consumer applications, particularly with the prompting inside a GPT. And we see so many providers one-upping each other. And so the consumer's getting better and better services on the language side. Now it's time to also, in a complementary way, think about the quantitative side. Can we have models that help us understand how to develop a new medication for Parkinson's, for Alzheimer's, for dementia, for cancer? These are quantitative models that have built into them the equations of chemistry. That's fundamental if we're going to make bigger progress, better progress in drug development, diagnostics. We'll talk about banking. We'll talk about energy. So these really need quantitative models as well.
Could you take us through also how you're seeing these kinds of capabilities that you're developing in the financial services sector? That's one that I'm very close to, and I know is top of mind. How can we stay at the competitive edge as a bank or insurance company or a payment platform? So how do these capabilities support the financial services? And I know you might want to break it down into sort of components of what the value creation is, but a lot of people are talking about productivity gains and time saved, but there's also the value creation side, which is the revenue uplift. So we'd love to hear what you're doing for the financial services.
So one framing point, building on what you just said, Alexandra, is that we can look at large language models as cost cutting, as ways of cutting the cost that normally would take humans X amount of time. We could do it in X, 50% of X or 25% of X or maybe 10% of X. And so language models really are about the cost cutting. If we have a set of analysts at a fund and they're normally pouring through lots of 10Ks and lots of financial filings on different companies they're managing and the portfolio of, then we can do it obviously in less time using language models. Large quantitative models are really about value creation. We talked a bit about value creation in the drug area, where again, you're using it to develop the actual new drug. But also now let's talk about the financial services area. One area of great interest to many of the largest financial platforms is in portfolio construction and optimization. When we think about the very primitive robo-advisors, right, that have been around now for several years, they basically give like a little pie chart of, a distribution of debt and equities. But they're really too simplistic to handle more sophisticated customers of the large private wealth management organizations and platforms. And so you need to bring in more dimensionality, higher dimensionality. For example, if you wanted to have structured products inside these portfolio that you're constructing, be it options or other kinds of structured instruments, the traditional robo-advisors don't really do a great job with that. And so using quantitative models to drive millions or possibly billions of potential scenarios for that particular portfolio, looking to see which one would meet up the needs of that particular client, that becomes quite interesting with large quantitative models. So a lot of value creation there, but also in terms of risk management. When we look at the overall risk analysis inside a large bank, inside an insurance company, inside of a fund, the traditional tools are not really cutting it anymore. Monte Carlo and others were developed decades ago in a different time, in a different space. And so given all the new complexity of our financial world today, the global nature of it, something happening in Hong Kong could obviously impact us here in New York and vice versa. We need to get to higher dimensionalities of representation. And one of the beautiful things about quantitative models today on GPUs is that we can go into those higher dimensional analyses, no longer just looking at one parameter. So to give you a concrete example, many of the stress tests that have been done in the last number of years on banks or on funds have really just moved one parameter up and down. Let's say interest rates as an example. But that's not how the real world works, right? Of course, in the real world, as your clients know all too well, Alexandra, many parameters are moving all at the same time. And that's where quantitative models shine. They shine when you have many parameters that you have to optimize for and understand what your tail risk is, given all those things moving simultaneously. So I think this is going to be a golden age for AI and financial services.
And that frontier can also be, I think you speak also about on the energy side and the energy sector. Maybe also just take us through what will be possible with this capability on the energy front.
Sure. Energy is obviously a critical sector for our economy in general, but now particularly with all the need for AI-driven data centers, for mass amounts of compute. People are searching high and low under every rock looking for energy sources to drive the compute of the future. And this applies to banks, by the way. So most banks that we engage with as customers of ours are about 80% still private cloud, private data centers that they either own or at least run and manage themselves. Only about 20% in the cloud at the hyperscalers. And so that means that banks also are looking for energy, right? They're looking for having a good resilient supply of energy and often looking for the renewable components of energy as well to make sure that the mix of the future doesn't add to the footprint issues. And so when we look at the energy sector, it must undergo a very significant transformation compared to where it is today, both in terms of absolute size of the supply of energy being supplied to the world, to power industry, to power data centers, to power other critical functions, but also the mix and the kinds of energy that we have and the resiliency of those energy sources as well. And so when we think about, for example, energy storage, storage is fundamental to the new grid, to the new way that we think about energy. But we need to move beyond the battery chemistry that we have today. The battery chemistry we have today is mainly based on a 45-year-old technology of lithium ion. And we know some of the issues there. We know that it's heavy. We know it's expensive. We know there's supply chain challenges of where the lithium comes from, where it's processed. 90% of the world's lithium for batteries is processed in one country. And I think we can guess which country that is. It's China. And so that forms a supply chain dependency, which is not favorable to resiliency in energy. And so one of the things we're doing with quantitative AI is looking at a much broader set of chemistries for batteries than just lithium ion and just the traditional mixes of anode and cathode chemistries that we've seen happen before. So I think that it's a very exciting moment. This is a moment of great opportunity, great potential, Alexandra, in the world of storage, as an example. And that will have a fundamental impact on how we think about the ready supply of energy, both traditional energy sources, but particularly renewable energy as well.
Yeah, it feels like it's a little bit of a race against time. So we're counting on you, Jack, on that one.
We're working it.
Before we end, just so interested just to hear maybe just briefly, you've just done a big capital raise. That's amazing. Just could you just give us a couple of sentences on, what you've raised? You've got some really exciting people on your cap table, and what are you going to do with the money?
Yeah, this is a critical time for growth for SandboxAQ, and we had a wonderful raise soon after we spun out of Alphabet. We raised $500 million in that initial round. Incredible set of very helpful financial backers, people who not only put capital into the company, but also their time, their network, opening doors, strategy, and so many folks, be it Jim Breyer, Breyer Capital, with so much pattern recognition that he has across sectors and the growth and scaling of companies. The mantra of SandboxAQ is deep impact at scale. Okay, so all those words are important. Yes, we're having deep impact, but also at scale. Mark Benioff has been very helpful to us in go-to-market, how to use both direct sales, but also channel partners. And we made some announcements already with Accenture as an example to scale our business. A lot of that comes from strategy sessions with Mark. Eric Schmidt, chairman of the company. The bigger we grow, the more he adds value because, again, he's built things to huge scale. Thomas Tull, very focused on dual use technology, somebody who's a leader and a thought leader in how do you have a technology that's great for both the private sector civilian world as well as for the national security world. And AQNav, one of our products, is a great example of that, where it's a quantitative AI that helps a plane navigate when there's no GPS. Of course, every civilian plane will need that, but also it's a national security issue as well. David Siegel, the co-founder of Two Sigma, great insight into the financial services world, Alexandra, that you and I discussed so much, and his understanding of quant finance and where the financial sector is going. Really helpful to have his insights. And then institutions as well. When we look at T. Rowe Price, a firm obviously focused more on the publicly listed funds, but beginning to make investments in the last 10 years in some private companies before they go public. S32, formerly known as Section 32, a great VC here in Silicon Valley that focuses on tech, biotech, and other emerging areas. Bill Maris, Andy Harrison is now the CEO over there. Andy Conrad joined in from Verily. Really great team over there. And so many others as well, Parkway and just many others that help us scale. So wonderful institutions and funds on top of the individuals that came in. But now it came time to really ramp up the company. In the first 2 years, Alexandra, of the company since spin out, we start to find product market fit. We start to get traction with a number of key referenceable customers in each of our sectors. And so we realized this is the moment to put pedal to the metal. This is the moment to take an additional raise. And we were able to not only have wonderful re-ups of the previous round of folks, but also bring in new folks. And an example would be Alger Asset Management. Fred Alger Asset Management, really strong institution, 50 plus year history on Wall Street. Publicly listed stocks is their main focus, just like a T. Rowe. But again, they could make some investments in privates who might one day be large public global companies. Incredible interactions with Alger, very smart folks. The lead person there is a PhD in material science from Stanford, and so really knows their stuff in terms of the quantitative world, and very, very helpful already in just since we closed the round with them. And then we have our first sovereign wealth fund, Mumtalakat, which is the Bahraini sovereign wealth fund, not just to have a financial return in our company, but also because they want to be customers of our AI products to drive the Bahraini economy towards a more diversified economy using IP as a focus. And for example, in biotech, in financial services, roughly 16-17% of the economy of Bahrain today is already financial services. They want to see that growing. It's already a great financial hub in the Gulf region. And so they want to use our AI for those applications as well. So great to see how that interaction is going. Rizvi Traverse and others who joined in this new round. So we raised over $300 million in the new round, bringing the total now across two rounds to over $800 million across these two rounds. And that gives us the firepower to really scale, to really focus on, number one, product development. That's our first use of proceeds. More engineers, more PhDs to ramp up scalable code. Our code exists on all the major hyperscalers and also our partnership with NVIDIA, scaling that as well. Second use of proceeds is go-to-market, is doubling down on not only direct go-to-market, but also partners like Accenture and Deloitte and many others like them, so that we can scale our channels that we have out there. When you look at a sales force, you can see the utility of having both direct and channels. So that's an area of investment for us on top of that. And also moving into new regions. The Gulf region is emerging to be very, very significant in their desire for advanced AI. And initially that was focused on language models, and now it's complementing that with interest in quantitative models. So regional focus as well, and we'll probably launch our first full-time set of folks in the Gulf region this year with this new money. So really proud of the team, and these folks, institutional investors, sophisticated investors, deep diligence on our company. I enjoy the process of these rounds because it really gives you, it's like putting a mirror up to your own face, and it really lets you look at your company in a new way. So it's a very, it's a wonderful two-way dialogue that we have with these investors.
Well, it's testament to all your hard work and brilliance that
and the teams, yes,
and the team, that they took a close look, and you raised a great chunk of money that sounds like it's going to be put to good use at a very strong valuation. So congratulations on that. That's I know it's a lot of work, and but I'm sure.
Thank you, Alexandra.
Great, as you say, and good to have behind you. But I know we've probably come to the end of our time together, and look forward to many more conversations with you, Jack. And I know we'll see each other in Davos in a couple of weeks.
Yeah,
where you've got a very, very interesting lineup of thinkers, speakers that will dive into these questions and a lot more in the snowy mountains.
Wonderful to be with you today, Alexandra. See you very soon.
Great to see you, Jack. Safe travels.
Take care.